Alright guys, we are getting to the second half of this chapter. What we'll be talking about the next couple of days is volume instead of surface area. So the first thing I need you to know is volume is the amount of space inside of a solid. Surface area was all about the space on the outside of it, how much, if we wanted to paint it, how much paint we would need to use if we wanted to cover it with something. But volume now is if we were trying to fill it. Like if you wanted to fill it with water, it's the amount of space that's inside of that solid object. Okay, so we have a couple formulas here. The volume of a cube, that one's kind of a shortcut formula. You can do side cubed, and that gives you how much space is inside of a cube. The volume of a prism is big B times H. Please notice this is big B, so big B still means area of the base, just like we were doing earlier this chapter. So this should be a pretty easy section because we're using all the same letters. And then volume of a cylinder is pi r squared H. The only other formula I want to throw in here is, you've probably seen this one before. If it's a rectangular prism, specifically only a rectangular prism, you can do the volume is length times width times height. Okay, that's a shortcut one, just like volume of a cube. And then the last thing we have on this page is just looking at what's called Cavalier's principle, which says that if you were to take a solid object and have the same cross-sectional area, so that same circle in the middle throughout the whole shape, and it just happened to tilt. If you notice the one on the right is tilted versus the one on the left, those actually will have the same volume because it's the same circle going all the way up and they have the same height. So this is assuming that this height is the same as this one, then they will have the same volume. So just something kind of cool to think about. It's just like taking a stack of pennies and shifting it. That stack doesn't have a different area if it's shifted. Alright, so looking at number 1, first thing you have to do is identify what kind of shape that is. That is a prism because it has lots of rectangles. So I'm going to use the new formula today, but then I'll show you the shortcut one as well. So the new formula says I have to do big B times H. So the first thing I'm going to tell you, again, like I was kind of trying to get you to do when we did surface area, and some of you did this consistently and some of you did not, is I'm going to highlight the bases. Whenever it's a prism, it should have two matching bases that are parallel to each other. So I'm going to decide that that shape is my base. So that has a side of 10 and 3. So then for B, big B, I have to find the area of that, which is going to be 10 times 3, which is 30. And then H has to be still the line that's connecting those together in the picture, which is going to be 6. That's what connects the two bases together. So then volume is just big B times H. It's actually a little bit simpler of a formula. So we get 180. But then we need to talk about how we label this. Because we're talking about the amount of space it fills, we use cubic inches because it literally would be saying how many little cubes could I fit in there. I could get 180 cubic meters inside of that shape. Okay? If you wanted to do the shortcut that you guys have been learning since, I don't know, 4th, 5th grade, that's just length times width times height, you get the same answer here. You're just using those three numbers, multiplying them together. Whoops, I didn't mean to put H there, I meant to put 6. 10 times 3 times 6 is also 180. So if you can only use that formula though if it's rectangular. So if you look at number 2, I cannot use length times width times height because it's not a rectangular prism. That's the only time length times width times height works. So this one I have to use this prism formula. I have to do big B times H. And please look carefully at what shape your base is right now. It's the shape that there's 2 of in the picture. I'm going to highlight them. It's not the bottom. It's these 2 that are running parallel to each other. It's those 2 triangles. So I'm going to draw that triangle out separately here. That is what we're worried about for big B. We're looking at that shape that is the base. And that's what I need to find big B for. So remember, big B means area of the base. So I need to find the area of this triangle. Since it's a right triangle, I can do 1/2 base times height. And they were nice here and gave me both of those numbers. So I can do 1/2 of 12 times 20. And that's going to be half of 240, which is 120. And then also be careful with the height here. Again, the height is the one that connects those bases together. So it's not necessarily always about the one that you're looking at that looks like it's up and down. It's actually a number we haven't used yet in the problem that's connecting the two triangles. The height is 6. So then to find the volume, we're just using the formula for today. Big B times H. That's going to be 720 millimeters cubed. Okay, let's try one more prism. Our last prism today also has triangle bases. So make sure you're recognizing that it's not about what's on the bottom, it's what there's two of. So I'm going to do big B would be finding the area of that triangle. Notice this one has tick marks on it, which hopefully tells you that that is an equilateral triangle, which means we have to use a different formula here. I have to do the side squared radical 3 over 4 formula. So that's going to be 6 squared radical 3 over 4, which is 36 radical 3 over 4. And you get 9 radical 3. And then H is the line connecting the two bases together, which is going to be that 18. So to find V for this one, it's just going to be 9 radical 3 times 18. So just be careful with how you choose to multiply those. To get those multiplied together, we're just multiplying the outside numbers, and the radical 3 is going to stay at the end of the answer. So I'm doing, so 9 times 18 ends up being 162. And then we get radical 3 centimeters cubed. Again, make sure you're cubing those since we're doing volume. All right, the other formula that you saw on the front page, I'm going to write it out, is for a cylinder. It's pi r squared times h. All that really does, if you look at pi r squared, that is our circle formula. And it just multiplies it by how many there would be if we stack them all up to get that volume. So we're just multiplying it by h. So I'm going to write down, just because I like to be organized, what R and H are first in the picture. R, remember, has to be only halfway across the circle. Right now that's saying the whole thing is 4. So R for this problem is going to be 2. And then the height is that line connecting the two circle bases together. The height's going to be 10. If you imagine standing that cylinder up on its bases, that's how tall it would be. Don't just look at how tall it looks like it is right now, but think about from base to base how tall it would be. So then I just plug in, that's going to be 2 for the radius and 10 for the height. And we are going to leave these in pi form, so 2 squared is going to give me 4, and then multiply that by 10, that's going to be 40 pi centimeters cubed. Okay? And then we're just going to talk about a word problem. So in number 5 here, it says a rectangular pool measures 25 feet long by 15 feet wide by 5 feet deep. A cylindrical pool measures 26 feet across the diameter and is 4 feet deep. What is the difference in the number of square feet of, shouldn't say square feet, but cubic feet of water that the two pools can hold? So to figure this out, we actually have 2 different shapes we're talking about. So I'm going to draw that out first. Those of you that aren't artistic, this isn't hard. Just do overlapping rectangles and connect the corners together. There's our rectangular pool. That one's 25 by 15, and then I'm specifically going to put the 5 here because that's how deep it is, so that's telling me the height. And then I have a cylindrical pool, so you can just do 2 ovals and then connect them together on the edge. And they told me the diameter across that is 26, and the height, the deepness, is 4. So we have to figure out the volume of each of these so we know how much water they can hold. So let's start with the rectangular one. To find the rectangular one, I'm going to use the shortcut formula. I'm just going to do length times width times height. So V is going to be, the volume for that one is going to be 25 times 15 times 5. And that ends up being 1,875 cubic feet. And then to do the second one, we have to use a different formula because this is now a cylinder, so we have to do pi r squared h. Careful, the radius is halfway across here. They gave me the diameter, so the radius would be 13. So it's going to be pi times 13 squared, and then the height was 4. So that's going to be 13 squared is 169 times 4 gives me 676 pi. But I can't compare those right now. I don't even know which one's bigger in that form. So please beware, anytime you have pi in a real world problem, you're going to use your pi button or 3.14, whichever one's easier for you to use. I'm going to multiply that by pi right now on the calculator. And it tells me that this volume right now is 2,123.7 feet squared. So this cylindrical pool, even though it's not as deep, it actually does hold more volume. And then we just need to answer the question. There is an important math word. If I read the question again, it says, what is the difference in the number of cubic feet of water that the two pools hold? So it's looking for the difference. So that should tell you to do the mathematical operation of subtracting. So that's all I got to do to get the final answers. I'm going to do the bigger volume minus the smaller volume. And that will give me 248.7 cubic feet. Ooh, I was writing square feet there before. Sorry guys, I'm just going to go back and fix it. Ignore me. It's Monday. My brain's not on. So just make sure for volume you're doing cubic feet. Alright, there are a couple problems for you guys to try on ClassKick, and then you have a homework assignment to do as well. Alright, we will talk tomorrow.